Hello and welcome back. In this part of the lesson, we're going to go through the examples dealing with probability. So if we look back, we went through some terminology and definitions already. And what we're looking at today is theoretical probability. So we're looking at that calculation of a ratio of a number of outcomes that make up an event to the total number of outcomes. And as I said earlier, until you see some of the definition or see some of the examples, it'll make more sense. So the formula we're going to be using is the probability of event A occurring is the number of ways A can occur divided by the number of total possible outcomes. And we talk about certainty. We're talking about less certain as closer you get to 0%, more certain as we approach 100. And the number always has to be between 0 and 100. If you have a number outside that range, you know you've done something incorrect. So the example, determine the probability for the following sums on a pair of dice. So we're looking at what's the probability of rolling a 4. Well, some of you have seen me create this chart. So dice 1, 1, 2, 3, 4, 5, 6. This dice chart wouldn't hurt having it handy because a lot of the textbook questions use the dice chart. So the dice chart basically works this way. These numbers on the top and down the side that I've just completed, they represent what came up on the dice. Inside then is the sum. So if you rolled 2 ones, you got a 2, a 1 and a 2, you get a 3, 4, and so on and so forth. If you roll a 2 and a 1, you get a 3, and then 4, 5, 6, 7, and an 8. And you get a nice pattern being created. And what it is, it's an easy reference to find the sums that you can roll on a dice. It saves you going through and trying to figure out all the different combinations. This chart has it all laid out for you right there. And 8, 9, 10, 11, 12. Okay, so when we look at the possible outcomes for rolling 2 dice, if we look at this box here, so all the numbers in here, there are 36 possible outcomes. Possible outcomes. 36 possible outcomes. It's a 6x6 matrix or 6x6 square, so there's 36 terms in there. What that means is that the number of possible outcomes, n of s, is 36. So when we're doing the calculations over here, probability of a 4, or a sum of 4, so probability sum of 4 will equal, again, that formula that we're looking at, probability of A is equal to n over A over n over s. Okay, how many ways can we get a sum of 4? If you look in your dice chart, there are 3 ways to get a 4. If you roll a 3 and a 1, a 2 and a 2, and a 1 and a 3. So there are 3 possible outcomes here out of 36 possibilities. And you can reduce that fraction. A becomes 1/12. So there's 1/12 of a chance. If you were rolling a pair of dice, there's a 1/12 of a chance that you will get a sum of 4. And you can always convert that to a percentage. Okay? This is about an 8% chance, so an 8.3% chance. I'm quite happy leaving it in fractions. The textbook sometimes converts to percentage and so on and so forth. So it's up to you really when it comes to that. The second one, a sum of 3 or 10. So we're looking for the probability for sum of 3 or 10. This is an example of rule of sum. You can't have both happen at the same time. You can't have a 3 and a 10. So you're looking at adding the possibilities here. So how many ways can we roll a 3? Looking at our dice chart, there are 2 possibilities. Plus, how many ways can we roll a 10? Down on this diagonal, there are 3 ways. So 2 plus 3 over 36, or a 5 in 36 chance. Okay, so 5 in 36 chance that you're going to roll either a 3 or a 10. And again, you can convert that to a percentage, and you end up with 13.9 or almost 14%. Okay, actually, no, 13.9 is correct. So you're more certain to roll a 3 or a 10. There's a higher certainty because you have a higher percentage. So keep that in mind. You have a better chance of rolling a 3 and a 10. Now, not a sum of 6. So what you're really looking for is the probability of rolling sum of 6, but it's a not, so we can put a prime in there in order to calculate that. So that sum of probability of rolling a 6, that prime indicates that we're looking at not doing that. How many ways can that happen? Well, we know that there's 36 possibilities in total, so we're going to do this indirectly. So 36 minus, how many ways can we roll a 6? Well, there's the diagonal there, and there are 5 possibilities. So 36 take away 5, so that's the number of ways it can happen, divided by 36. So it's a 29 in 36 chance. Oops. So quite a bit better chance on not rolling a 6 than the previous 2 examples. So that approximately comes out to an 81% chance. So we have an 81% chance of not rolling a sum of 6. All right. Finally, a sum of 13. So this is just making sure you understand. When you look at the dice chart here, nowhere in the dice chart do you see a sum of 13. The highest number possible is a 12. So there's no 13 in the chart. So there's a 0 in 36 chance, which is a 0%. So you are absolutely certain that you will not roll a sum of 13. However, the other chances here, the other ones we talked about, are varying degrees. All right, and on to the final example. We now have a set of numbers, so very similar to the set theory homework you did last unit. The first question here, the probability of picking a number that you can take the square root of. So that's a perfect square. So the probability of a perfect square, PS, would be, well, we need to find all the perfect squares in that set. So 1, 4, 9, 16, 25, 36, 49, 64. You can take the square root of all of those numbers. So we have, what do we have up there? 8. So there's 8 over 8, which translates to 1, or 100%. So this is like the sun rising. Okay? There is a 100% chance that you will pick a perfect square from that set of numbers. Picking an even number, okay? Remember that's got to be divisible by 2. So the probability that we have an even number. So I'll change to red on that. Even numbers are divisible by 2. So our 4, our 16, 36, and 64. So counting those up, there are 4 possibilities. And there's still a total of 8 numbers. So that's a 50-50 chance. So you have a 50-50 chance, or 50% chance, that you're going to draw a number divisible by 2. Picking an odd number. Now, picking an odd number is the same as saying it's not even. So I'm doing this one a little bit different. You can still go through and count all your odd numbers. So you'd have a 1, a 9, a 25, a 49. You can still do that. To save yourself some time, odd is the opposite of even. We already know up here what even was, and I said it always has to be 100%. So if you take the 100% and subtract, we found was 50, you can find it's a 50% chance of getting an odd number. Now for all of these, remember with the word problems, you do need your therefore statements. And finally for D part, picking a number divisible by 5 or 6. So a probability of divisible by 5 or 6, and you can short form it inside the brackets here. I'm not too picky as to how you write it up, but you need to make sure you understand what you're finding. So not divisible by 5 or 6. Or sorry, a number divisible by 5 or 6. So that means it has to end in a 0 or a 5 for our first part here. So that's divisible by 5, and that's it. Divisible by 6, you always check. You have a calculator, so you can always double check. 36 is divisible by 6, and your 64 is not. So you only have the two possibilities. So there's a 2 in 8 chance, which reduces to a quarter, or 25%. So 25% chance you pick a number divisible by 5 or 6. So that's your basic probability. The key to this, again, basic probability is this formula right here that I have circled in the red. All probability for us this semester will come back to this formula at some point. So with this, all you are simply doing, you are trying to find how many ways can what I'm interested in happen, how many ways is there, how many different outcomes are there? So you're figuring out, you're just creating a fraction, and that's as far as dealing with fractions will go. All right, good luck with the homework, and we'll talk to you in the next lesson.